Hi, this video is about problem number 78. Hopefully you've already watched the review on how to work with percentages of a number because that will make this one a little bit easier. So before we actually start solving the problem, it's always a good idea to read it and try to understand it. So this one has a fake news article in it, so follow along while I read it to you. Pie Pods sweep the nation. Millions demand one. Teenagers and Hollywood celebrities flocked to an exclusive shop in Beverly Hills, California yesterday, clamoring for the new Pie Pod. The store will have 100 to sell the first week and expects to receive and sell an average of 15% more per week after that. I plan to stand in line all night, said Nellie Hillman. As soon as I own one, I'll be cooler than everyone else. And then it's cut off there. But the idea here is that the amount that they have is increasing over time, and we want to see how that's happening. So problem number 78, I'm reading the directions here. Thanks to the millions of teens around the world seeking to be just like their math teachers, which I know includes you, industry analysts predict that sales of the new portable math problem generator called the Pie Pod will skyrocket. So we're going to see exactly how they skyrocket. Letter A, if sales of Pie Pods continue to increase as described in the article at right, how many Pie Pods will be sold in the store in the fourth week after their release? So I think the best way to go about any of these problems is to start with a table. Personally, that's just the easiest thing for me. So I made a table. So make sure you keep your book open here, but I'm going to switch over. So here's a table that I made where n is the weeks after release, and t of n, basically the y, is the number of Pie Pods sold. So it says the first week they expect to have 100, and then it increases by 15% after that per week. Now you'll notice that I started at 0. Part of that is just because I think it's easier to start at 0. Sometimes it does make sense to start at 1, and maybe this might be surprising to you since it said like the first week they're going to have 100, then that'd be a good time to start at 1. But I've also done this problem before, and like letter A says in the fourth week after their release, and so that to me says that like the first week after their release would actually be one down the line. So this is why I've set up my table this way. Anyway, this is I think it's the hardest part of this chapter to be careful about the language there. Anyway, so the next week they're going to have 15% more. So what I want to do is find what 15% more would be. So I want to multiply that 100 times 0.15 because that's what 15% is. Hopefully you already know that it's 15, but then here's the wrong answer. It's not just 15 Pie Pods are sold in the first week after their release. It's 15 more. So total is 115. Basically, you got to take your number that you get by multiplying by 0.15 and then add it on. Now, here's another wrong answer. For the second week after the release, the first place we want to go is 130, but that's not right, and here's why. 15% is now different. So now I need to find 15% of 115, which is going to be a different number. And I forgot to have my calculator here, and I can't switch screens to Desmos like you can. But what you should be doing right now is 115 times 0.15. So when I do that, I get 17.25. Now, if you're not thinking about this too deeply, you would just add 17.25 to 115, and you'd write 132.25 in the table. But I don't think that makes sense. Because you can't have like 0.25 of an electronic device. I'm sure they're not going to be shipping one that's been cut into force. That would be not exactly everybody's favorite one to buy. So I'm going to round off. And then you have to continue like this. Okay, now we need to find 15% of this. 132 times 0.15. And that's rounds off to about 20. And then I do that one more time, 152 times 0.15. And if you're following along, again, I'm rounding off here. And I got 22.8, so that rounds off to 23. 23 more. So again, I'm not just writing 23 in the blank, I'm writing whatever 152 plus 23 is. I think that's 175. So I know my table goes farther, but I'm done with letter A right here. How many Pie Pods will be sold in the store in the 4th week after the release? 175. Now letter B says how many will be sold in the 10th week, and that's why I have it going down to 10 because we're going to go ahead and do that. Now there's a shortcut. It's not that much easier, but it will save you a little bit of time. Instead of taking 15% and then adding it to the previous one, the same thing is finding 115%. Let me show you what I mean. So instead of finding 15% and then adding it on, if I just multiply by 115%, I get the same thing. Now, maybe I shouldn't have put equal signs there because I rounded off. So it's about 175, but that's a shortcut. Instead of multiplying by 0.15 and then adding it on, that'll always work. You can also just multiply by 1.15. That's a shortcut. And hopefully you see where the 1 comes from and you see where the 0.15 comes from. You'll do a couple practice problems later on, but I'm going to continue on by multiplying by 1.15 each time and then putting my number in the blank. And I'm not going to show my work here, but that's the idea, 1.15. Again, I'm rounding off here to I'm rounding off to the nearest whole number. I guess it would also make sense to just always round down in this case. I don't know, you can totally convince me of that. So depending on how you rounded, it should be about 405 in the 10th week. All right, letter C. If you were to write this as a sequence, which would basically just be all the T of N's, Tn column, just listing those, what type of a sequence would this be? Arithmetic, geometric, or neither? So is it arithmetic? Does it add the same number every time? Does it multiply by the same number every time? Or is it neither and then it's just like a weirdo? In this case, this doesn't add the same number every time. Like the first week it's added 15, and then into 2 weeks after it's added 17, so it's changing. And then it's 20, so it's even like not really a solid pattern there that I can find. But it is geometric, and that comes from this that we're multiplying by basically 1.15 every time. And that's a good justification. Why is it geometric? Because it's multiplying by 1.15. Now, letter D, it says to write an equation. But I'm going to go ahead and write both forms of the equation. So since we're under the geometric column, we should be looking on the board on the right side. Here's the explicit formula. I have to put some numbers in the blank there. And hopefully you've done enough of these that you've seen the pattern. Like if you're looking up on the board, the red part is where it starts, and then the blue thing is what it multiplies by. Hopefully you've noticed those patterns. If you haven't, just start to memorize those now. And if you mix them up, you can always use your calculator to, like if you mix them up, you'll enter it in, you'll look at your calculator, and you'll be like, wait a minute, this doesn't work. So anyway, for this one, starting value is 100. Starting value is 100, and then the multiplier for this one is 1.15. Sorry, that's a little scrunch, but that's the idea. 100 times 1.15 to the power of n. That's the version you can type into Desmos or a calculator, and it'll work out. You can see the table, and it should match pretty well what I have. It won't be exact because I rounded, but close enough. Here's the second version, recursive. I'm going to start with A0 because I think that makes sense for this one. A0 equals 100. And then the second equation has to be like an AN equals AN minus 1 thing. And that's just saying, that second equation is just saying, to get the next term, you take the one before it, and you multiply by 1.15. So those are the two different versions. There's the explicit, this one equation, and then there's the recursive, that is actually two equations. You need both of those to describe the sequence. You got to say how it moves and where it starts. So that's it. Hopefully the rest of the classwork goes pretty well for you. Good luck.